on page 5, a number 5. What I like about it is it really goes back to what we were talking about yesterday. We're kind of circling back. All right, Coop, so let's put that computer away. Okie dokie. It says a particle is moving along the x-axis. That's what we're doing this year, y'all. We're just going left and right. And it said the velocity is given, I hate when I do this, from 0 is less than t is less than 6. I just hate when it's wrapped on the side. So it's just saying for up to 6, and they gave us no units. So 6 blanks. And then again, I'm just going to remind myself, this is a velocity graph. They said the velocity is 0 at 0, and I agree, that point is right there. The velocity is 0 at 0, 3, and 5. Okay, they gave us that info. And the graph has horizontal tangents, it says, at 1 and 4. And if it has a horizontal tangent, that's like this, 1 and 4. Okay. Is the particle speeding up or slowing down between 5 and 6? Bless you. Is everything okay? So is it speeding up or slowing down? Reminder, for something to be speeding up, my velocity and acceleration have to have the same sign. If it's slowing down, the velocity and acceleration have different signs. And again, you don't have to write that down if you don't need that. But from this velocity graph, how the heck am I going to figure that out? Let's talk velocity of this graph between 5 and 6. The velocity, if this is a velocity graph, what are these velocity values, positive or negative down here? They're all negative, right? So down here, my velocity, they gave us no units. We got negative something. My velocity is getting slower because it's approaching 0. So I was just going to the left, I sped up, and then I still am going to the left, and I went to 0. Then I turn around and I'm going to the right, I sped up, and then still going to the right and I approach 0. And then I turn around. So over here, my velocity is positive or negative? It's negative, right? And that just means I'm going to the left. It's speeding up and going to the left. So I'm just going to say my velocity is negative. And what about my acceleration? How am I going to get acceleration from a velocity graph? The slope, so good, Henry. Over here, between 5 and 6, would you say if I drew some tangent lines, those tangent lines have positive or negative slope? Negative, they're all going down. So I'm going to say the acceleration was also negative. So because my velocity and acceleration have the same sign, would we say it is speeding up or slowing down? Speeding up, you know it. So we're going to say speeding up because velocity and acceleration have the same sign. But we have to say when. So we're going to say from, they say 0 less than or equal to t is 6, and I got that right here up in my problem. Yep, it should be 5 to 6 to match this. Silly me. Thank you, B. Bless ya. Okay, during what intervals is the acceleration positive? Acceleration positive. This is a velocity graph. We just got acceleration, as Henry said, over here by looking at the slope of velocity. The slope of velocity gets acceleration. What's the slope of the velocity over here? Negative, and then it's 0. What's the slope after? Hey, what's the slope here? What's the slope here? And then 0. So from what x to what x could we say that acceleration is positive? I think it'll be actually from 1 to 4. And the reason I get to say 1, because look what they said. That horizontal tangent is at 1. You know what I'm saying? So it'll start from 1. And I see what you're saying. You're like, it kind of looks flat after that. I think it's just kind of a crappy graph. If they're saying it was horizontal at 1, it's going positive, even though it's just a little positive right after that. So we're going to say 1 is less than t is less than 4. Or you could say from 1 to 4. Either of these notations is totally fine. And what's that justification? We're going to say the slope, I'm going to say because, the slope of, I'm going to use exactly what they named this. This was a v of t. I'm going to say the slope of v of t was positive. Okay, number 6, the position. Okay, and again, these words are so important. Position was given. And then it says, what's the particle's velocity? Coop, I just want to make sure that you're good with this. Did you do this one without a calculator?
Yeah, I did this one without a calculator.
All right, if we got position was this, velocity is its derivative. So if s of t was position, S prime of t is going to be velocity. Derivative of sine, cosine, leave the angle, times 5. You got it, bud. You could put that 5 afterwards, but I'm going to just throw it in front. That's the velocity at any point in time. This was chain rule right there. The acceleration is just the derivative of velocity. So I'm going to just call this S double prime. Ooh, the derivative of 5 cosine. -5 sine. Because the -5 is chilling, the derivative of cosine is negative sine. Leave my angle times the derivative of my angle.
5.
Good. So
negative
25 sine of 5t, right? That's good, that's good. That's good, sir. And then it says, well, what was that velocity when t is pi? So I'm going to go back to that velocity equation, and I'm just going to go throw a pi in there. So I'm going to say, all right, S prime of pi is now 5 cosine of 5 pi. 5 pi's, what the heck? Here's a unit circle. Oh, 1 pi, 2 pi, 3 pi, 4 pi, 5 pi. Cosine there is a -1 times 5, -5. You go it. Acceleration, I don't know why I split these up like this. Acceleration when t is pi over 10. Wow. Acceleration when t is pi over 10. So I'm going to go use that acceleration equation, which was, yeah, you're like pi over 10 is not on the unit circle, but it was the sine of 5t. So it'd be 5 pi over 10. Good call, Coop. I'm impressed, Cooper Mead. And then 5/10 of a pi is just pi over 2, 1/2 of a pi. So I'm at -25 times the sine of pi over 2.
which would be 1.
Yep, the y value up here is 1.
Would just be -25.
Yes, sir. That's going to equal to 6. Whoa. Here we go. Okay, particle moves along a straight line. Here's the velocity. This is velocity this time. And its position is s of t. Okay. Find all the times where the particle changes directions. What the heck? What's my velocity right now? Positive. What's my velocity right now? Negative. So do you agree that when my velocity changes signs, I change directions? So when it says justify your answer, let's write that first because it helps us know what we're looking for. A particle changes directions when velocity changes signs. So let's go and say, whoa, that is a fat pen. The velocity changes signs at. And that's when we're going to go use our calculator, but we're looking for this info. So now let's go use our calculator in our graph mode. And this is the velocity, right? So I don't have to type in derivative. I don't have to do math 8. I'm going to go into my y equals screen, and I'm just going to go type in that velocity. So in my y equals, I'm just going to go type in -2 plus parenthesis x squared plus 3x, and then to the 6/5, and then minus x cubed. So we got this picture. Whoa. Stay with it. Stay with it. Ooh. Okay. Here's the deal, you guys. This is the velocity graph. So I'm even going to sketch. This was the velocity graph, and it was like this. Woo! Total sketch. Doesn't matter, you guys. Doesn't matter. This was the velocity graph. We said a particle is going to change directions when the velocity changes signs. If this is a velocity graph, what are these values here? Positive. What are these values here? Negative. So you guys, it would change signs boop in blue. Would it also change signs in boop blue and boop blue? Yeah, because the velocity was positive, negative, positive, and then negative again. It's a good thing we didn't have to look at my terrible graph.
But we ignored the first one because it says from 0 to 5.
Oh my gosh, great call, people. Great call. So here's what I want you to also get used to. When they give us this window range, Cooper, you are just killing it for me today. This is like it already knew it. This is funny. Everybody go to your window and make your x min 0 and your x max 5, and now graph it. And to Coop's point, it's only looking ish around like this now, isn't it? Because we aren't talking about, we can't go back in time. We can't have negative x values. So now we still want these two blue values. Those are called zeros. So let's go do second trace 0. Let's see if I actually get the right one this time. If not, I've definitely done something wrong. Did anyone get 0.536? Yeah? Okay. So I'm going to say at x equals 0.536, 3 decimals all day, every day, right, Marmar? 3 decimals. And then I'm going to do a second trace 0 again. And I'm going to go scroll over to the other one, and I'm going to do left bound, enter, right bound, enter, enter. And I got 3.318. Great. Okay, here we go. Is the speed increasing or decreasing? Is the speed increasing or decreasing at t is 4? Let's go back to our graph, and I'm going to do trace 4, enter. Whoops, trace 4, enter. Oh, I do? But I thought my window was from 0 to 5. Yeah? Where is 4 on yours? Oh, you had it, and then do trace 4, enter. Oh, yeah, sorry. I think I misconfused you. So we're going to just do trace 4, enter. And that's, oh, I see what you're saying. It's negative. Yeah. I see what you're saying. You're saying to see it, I'd have to zoom out because that y value is negative 11 or something. Perfect. Okay. So what does that tell us? That you agree my graph looks like so. My graph looks like so. Woo, right? And they're saying when x is 4, my y is somewhere down here. 4, negative 11 point something, something, something. Okay. Is the speed increasing or decreasing? So we got to think. What do you think? Why do you think? That's so right.
Negative slope and it doesn't make sense.
Yeah, you're saying my velocity at t is 4, do you guys agree, is negative 11 point, what was that value? Did you have that there? Negative 11 point, give me 3 decimals.
476.
Thanks. So my velocity is negative. And then we got to look at my acceleration. My acceleration at t equals 4. How did you know it had a negative slope, buddy? You're like, when I draw a little tangent line, it would be in the negative direction instead of the positive direction. You're right. So I'm going to say is negative. So we said it's going to be speeding up. And with that rationale is what we're looking for. Speeding up at t is 4 because velocity and acceleration
Have the same sign.
exactly. Acceleration. You could say are both negative or have the same sign, whichever you prefer. Have same sign. Good job. Let's try this. Next guy, it says, hey, position. Position is given. Whoa. When is that particle at rest? Again, this early in the game, you guys, maybe you're reminding yourself, anytime the particle is at rest, the velocity is 0. If you don't need that note, don't write that note. But if you do need that note, write it down. Could I get velocity if they gave me this position info? What do I have to do to get that velocity?
Take the derivative.
Take the derivative. Let's go find x prime of t. X prime of t is going to be what, y'all? 6t to the second minus 42t plus, boom. Ew, you guys, if we got to set this equal to 0, we would have to O2 it if we left it like this.
Yeah.
Could we factor something out instead?
6.
Yeah, let's take a 6 out. If I factor a 6 out, 6 goes into 42 7 times. Ooh, 6 goes into 72.
11.
Close.
6.
Goes into 72. 12 times, right? Because 6 goes into 36 6 times.
Yeah.
36 doubled is 72. 6 doubled is 12. Love it. Okay, you guys, now tooting this is so much easier. Okay. Okay, guys, what multiplies to be 12 and add to be negative 7? Negative 4, negative 3. Well said. Well said. T minus 4, t minus 3. When does this equal 0? Does 6 ever equal 0?
No.
No. Does t minus 4 equal 0?
Yep.
Yeah, at t is 4. And? Is that an answer? E. So now it says a particle, the velocity is given. So again, letting yourself know that one's velocity. And so maybe you're like, oh, velocity, or maybe just above this or below it, you write velocity. Which of the following statements describes the motion when t is 1? And it's saying, oh, moving left and right and acceleration, and we get a calculator. So if I need to know if something's moving left or right, if it's moving right, the velocity is, and if it's moving left, the velocity is. So how would I find the velocity at t is 1? There's the velocity equation. So what can we do?
Just plug it in.
Plug it in. Let's go find v of 1, the velocity when t is 1. And you guys, you can type that right in your calculator. You can type in root 1, but I hope that we all know root 1 is 1. Root 1 is 1 minus the cosine of e to the 1. And make sure that you are in radians. All right, did anyone get a number? 1.912? Yeah? Is that positive or negative? It's positive. So we just note my velocity was positive. My velocity is positive. How the heck am I going to get acceleration? Acceleration is the blank of velocity. Derivative. Could my calculator find the derivative of that velocity? Yeah, it can. You guys, we can go math 8, that velocity function. So I'm going to math 8 root x minus the cosine of e to the t. Notice that I put the variables in. Whenever I ask for a derivative, you got to type in the function with the variables. And then it says, wait, where do you want that derivative? When x equals what? And that's when we're going to say when x is 1. So then I'm going to go type in a 1. Ooh, and I got my acceleration to be what?
Positive.
Equals my acceleration, and my acceleration was 1.617. They were both positive. Which one? B. He says, we're moving to the right because my velocity was positive. I like moving to the right. That one's out, that one's out. And then you said my acceleration was also positive, so I agree with B. Good job. B is for biscuit. Negative acceleration, we would have just gotten a negative answer there. Okay, we can do this, people. Let's try one more. Whew. With a calculator. 2003. You guys were not alive. No, I'm not alive. Okay. Particle moves along the x-axis. Ooh, velocity is given. What would I do to find its acceleration? If I gave you velocity, we got to do what to get acceleration? Take that derivative. You got it, you guys. So I'm going to go math 8 of that velocity. 3 plus 4.1 cosine of 0.9x. And where do they want that derivative? When x is 4. Is that an answer? Yeah. And then we're done. Top one. It says, this top one, because this is 2015. It's a little bit more recent. It says they gave you the derivative, and then they want the acceleration equals 0 at what t value? So that's really asking for an x. So we're not plugging in 0. It's saying the acceleration equals 0 at what x? We get a calculator. We have this, since this is dx dt, this is really the velocity. They're letting us know that's the velocity. What could I do to this to get the acceleration?
Derivative.
Take the derivative velocity and we get acceleration. So I'm going to go to my calculator. I'm going to go into that, I'm going to go to the graph because they want to know when it's equal to 0. So I'm going to look at the graph of it. I'm going to do math 8 of negative 10x to the 4th plus 9x squared plus 8x. And I want them to graph the entire derivative. So notice I say when x equals x here. Since I'm graphing the derivative of velocity, I'm graphing acceleration. Boom. And I'm going to go hit zoom 6 to go back to a normal-ish window. Does anyone's kind of look like this? And yours might be a little different, but is it kind of like that? Look at what it's saying one more time. It's saying the acceleration is 0 at what x? What function do I use of my calculator?
0.
Second trace 0. Hi, this is Laura. Hey, girl. Yes, ma'am. No problem. Bye-bye. Lob, Mrs. Berlin wants you to sign out at the end of the period. Okay. You guys, did anyone get it? I'm not getting it. Second trace 0. I don't even see my cursor. Oh, there's my cursor. To the left, to the right. Did you get 1.021? Nope. So did I. I was looking at the wrong thing. 0.831? That's it, y'all.